Now we will discuss the other conic sections, specifically the parabola, ellipse, and hyperbola. Okay, so conics or conic sections. So a conic is the locus of a point moving so that its distance from a fixed point called the focus is on a constant ratio or eccentricity to each distance from a fixed line called the directrix. Okay, so we have this example for conic here. Okay, so ito yung conic, guys, no? Ito yung conic natin. Then, so with this conic, so we have this axis of conic. Okay, then we have this directrix. Then we have this lattice rectum. So we have this vertex, focus, then a chord. Okay, so we'll define each of these components. Okay, so the line perpendicular to the directrix and through the focus is called the axis of conic. So ito, guys, so this is perpendicular to the directrix and also with our focus here. Okay, so the point of intersection between the axis of conic and the conic is called the vertex. So here, okay, that is a vertex. So this is your conic, then this is your axis of conic, so this is the vertex. Okay, then a line segment joining any two points on the conic and through the focus is called the chord. Okay, so say with this point here and also we have this point here, so if we connect that, then it will pass through our focus, then that line is our chord. And a chord that is perpendicular to the axis of conic is called the lattice rectum. So this is our lattice rectum. So again, we have this one point here and this point at the other. Okay, so if this chord is perpendicular to the axis of conic, then that is a lattice rectum. Okay, so that's why this point here is L, then this point is R. Okay, for us to easily determine that it is lattice rectum. Okay, so these sections are called conics because they can reveal by passing a plane through a cone, except for a circle that is the limiting shape of an ellipse with eccentricity approaching 0. So the following are the conic sections. So this is the reason why they're called as conic sections, because these sections are being derived or created in a illustration of a cone. Okay, so we have this cone here. So if we pass through a plane, okay, so if we pass through a plane in this cone, okay, so what we can create here is an ellipse. Okay, so that's an ellipse. Then if we pass through a plane horizontal, okay, horizontal to the conic or the cone, so we have this circle here. Okay, then if we pass through a plane in this manner, so we have this parabola here. Okay, another parabola there. Then if we pass through a plane vertical, okay, in two cone at the upper portion and the lower portion, so these two shape here or sections will be our hyperbola. Okay, so now we will discuss parabola. Okay, so from the species of conic, we have already known that that a parabola has an eccentricity equal to 1. Okay, so a parabola is the locus of a moving point so that its distance from a fixed point focus is equal to the distance from a fixed line directrix. So what does that mean? Okay, so meaning, so the locus of a moving point, so that is any point on your parabola. So say in this case that is point P. Okay, so that is point P. So that its distance from a fixed point focus, so we have this point, the locus to the focus. Okay, so say that is df. Okay, so that is distance df. Okay, so that is distance df is equal, okay, so is equal to the distance from a fixed line directrix. Okay, meaning that is from the point or from the locus to the directrix. Okay, so this line here. Okay, so say that is d sub d. Okay, d sub d. Okay, so that is the definition of a parabola. Okay, so we have this, the distance from a locus to the focus is equal to the distance from the point to the directrix. Okay, so this formula here is being derived with this concept, okay, or with this definition that we have in a parabola. Okay, so df, so since that is a distance, so we have 2 points there. Okay, so that is the points from our focus and point from point P. Okay, so we will be using the distance formula. Okay, so I think you have already know what is a distance formula. So we have x minus 0 squared then plus y minus p squared. Okay, and from the illustration, as we can see that d sub d is this distance here is p. Okay, so ito. Then since the coordinates of this point p is x and y, so from the origin to that point, so that is equal to y. Okay, so that is equal to y plus p. Okay, so if we squared it both sides, okay, so square both sides, so we have x squared. So we have x squared plus y squared, then minus 2py. Okay, so that is the expansion of this equation here. Okay, then plus p squared. Okay, then equal to, again, this is the expansion of y. Okay, so ito magiging y plus p squared yan siya. Okay, so you will be using a FOIL method. Okay, so you have y squared plus 2py then plus p squared. Okay, so you can see that y squared, okay, this will be cancelled out. Okay, so then if we transpose that to the other side, okay, then also p squared and p squared cancel out. Okay, so if we transpose it there, so we have x squared is equal to 2py, so transpose to the other side, so the sign will be changed to 2py. Okay, so therefore x squared is equal to 4py. Okay, so this equation is the same equation in here. Okay, and take note that Lattice Rectum is equal to 4 times p. Okay, so if Lattice Rectum is equal to 4 times p, then the equation can be also written as x squared is equal to Lattice Rectum times y. Okay, so that is the equation. Okay, so standard equation for the parabola in this form. Okay, in this form in here. Okay, so what I wanted you to do is to familiarize the elements of a parabola. So if this is your parabola, so you have this focus here. Okay, so distance from the origin, so this is the origin, guys. Okay, distance from the origin to the focus is P. Okay, so P distance. Okay, then also the distance from your origin to the directrix is also P. Okay, then the points of your focus here is 0, 0, then P. Okay, and also you have this Lattice Rectum here. Okay, so that is perpendicular with your axis of conic. So now, so these are the concavities of your parabola. Okay, so we have this case, so this is concave upward. Okay, so your equation will be x squared is equal to 4py is equal to Lattice Rectum times y. Okay, then if we have a parabola concave to the right, then we have this y squared is equal to 4px is equal to Lattice Rectum x. Okay, so all of this is positive. Okay, so positive siya if the parabola is concave upward and to the right. While if it is concave to the left, so your equation will be y squared. Okay, y squared is equal to negative. Okay, so negative 4px. Okay, then if that is concave downward, then you have x squared is equal to negative 4py, or that is equal to negative lry. Okay, so negative again. You have this negative sign here. Okay, so this will be your equation if your vertex, okay, is at origin. Okay, so how about if your vertex is not at the origin? Okay, so say, so this is concave downward. Okay, so your vertex is hk again. So what you will do is, so this will be your standard equation now. Okay, then if this is concave upward, then this will be your equation. Okay, then if it is concave to the right, then this will be your equation. Okay, so just put a negative h here at your x and negative k at your y. Okay, so take note that your h is at x, then your k is in y. Okay, so take note of that. Okay, so yk, then x minus h. Okay, if it is concave to the left, then this will be your equation. Okay, so those are the standard equation of your parabola. Okay, so from the general equation of a conic, so these were introduced already last time with the species of the conic topic. So we observe that it represents a parabola if either a or c is 0. So therefore, when a times c, okay, so from the general equation is equal to 0, then your conic is a parabola. Then the general equation of parabola is either this way. Okay, so in this case, your c is equal to 0. Okay, so eliminated. The equation for cy squared is being eliminated. So if your general equation for parabola is written in this form, so that is either open upward, okay, open upward, or open downward. Okay, so if a is equal to 0, then cy squared plus dx plus ey plus f is equal to 0, then that is either open to the left or to the right. Okay, so these equations can be reduced further to after dividing through a or c. Okay, so the same with the circles, guys. Now we have this reduced form of the general equation. So what will happen is x squared plus d. Okay, so this will become a small d, small e, small f. Okay, so meaning d is equal to big D over a. Okay, so same with e, big E over a. Same with f, big F over a. Okay, so open upward, so we'll know that it is open upward if your if the value of this is in negative. Okay, so that is in negative. Then also you will determine the length of the latus rectum by just looking at the value of E. So that is equal to the absolute value of E. Okay, so if this equation here divided by C, then that is open rightward if D is in negative. Okay, so your latus rectum is equal to absolute value of D. Okay, so these are just a trick, guys, if given if the given is a general formula of a parabola. Okay, so lastly, so we have this square property of a parabola. So we have this parabola here. Okay, so we have this parabola here with the width b, then with the height h. Okay, so say you will be going to determine the value of this x or the value of this y here. Okay, so if the section is a parabola, then you will be using square property of a parabola. So how to do that? Okay, so you have y over x squared. Okay, so you have this y, okay, then over x squared. Okay, or that is the small parabola. Okay, so y then x, okay, for this, then equal to the big parabola. Okay, so b, then we have this h. Okay, so it should be consistent, guys. If the width is being squared here, x is being squared. Okay, so x squared being squared, then also for the bigger parabola, then the width should also be squared. Okay, so x squared then b squared. Okay, so also you may use half of the distance of the width. Okay, so may also use x squared. Then if you use half here, then also use a half width here, the bigger parabola. Okay, so do not forget the square property of the parabola because this will be part of the application. Okay, so area bounded by the parabola in its latus rectum. Okay, so earlier we have already discussed. Okay, so you have this latus rectum here. So latus rectum. So this is AP. Okay, so area bounded by the parabola in its latus rectum. So since the area of a parabola is 2/3 of b times h, so this is area of the parabola, guys. So this is the area of the whole parabola, and in this case b is equal to LR. Okay, okay, then h is LR over 4. Okay, so this is LR over 4. Okay, so take note that is p distance. Okay, so that is 2/3 of LR times LR over 4. So therefore, the area bounded by the parabola and its latus rectum is equal to latus rectum squared over 6. Okay, so if we will be computing the area of the whole parabola, okay, so given height and b, so area of parabola is 2/3 b times h. So that is a whole parabola, but in this case this is only for area bounded by the parabola in the latus rectum, so this portion here. Okay, so that will be the introduction for parabola, guys. We will solve problems regarding with the concepts, so stay tuned in our part